Okay, guys. So today we have still not completed the dual nature of radiation. We still have left with two more sessions. So maybe today or tomorrow we'll be able to complete this chapter. Okay. Okay. So today we'll study wave nature of matter. Wave nature. Till now we have studied particle nature. Yes, photoelectric effect we have studied. So that is all about the particle nature. Okay, light as a particle. Now we will study the wave nature. Light as a wave. So we'll study what is de Broglie hypothesis. So after the photoelectric effect, it was well known that radiations has dual nature. Okay, everybody knew that light behaves as both particle and wave, and the particle nature uh, had three experiment. Okay, one is the photoelectric effect, what we studied, and in your syllabus you have photoelectric effect only. There is one more called Crompton effect. Crompton effect. CROMP, Crompton effect. Just know these names are called scattering effect. And the third experiment was black body radiation. So these experiments proved that light is a particle. And so what else was there for wave? For a wave, it was interference, diffraction, and polarization. These are the three experiments which proved that light is a wave. Clear? Yes? You will study more about this in your, if you're taking science as a major, you will study about this in your BSc. If you're taking BSc physics, you will study more. Polarization you would have studied already. Yes or no? Polarization you already would have studied. Yes? Polarization you know, no? What is polarization? Light as
Yes,
a
sir.
light as electromagnetic waves. Huh? It has two. So you use a polarizer, analyzer. So what it does, if the polarizer rotates by your axis, okay, it will only amount that certain amount. Slowly, if you rotate more, if the axis is matching with the this one, so full intensity goes. So if it changes, there is something called Brewster's law. Remember Brewster's law. So Brewster's law is one of the law which is in polarization, which you would have studied. More about that you will study in your BSc. Clear? So gathering and passing of light by eye lens is called wave nature. Absorption of light by retina is the particle nature. Remember this. Gathering and passing of light. Gathering and passing of light. Light will gather, no? You have an iris. Yes or no? Eye. This will, there is an object. So what it does, this is your retina. So what happens? This falls like this. Yes or no? The gathering and the passing of light by eye lens. You have an iris and you have a lens here. Lens here. The lens is, how the lens is? The lens is a convex lens. Yes or no? Studied biology or not? It's a convex lens. Yes, in the eye you have a convex lens. So that is wave nature. But absorption of light by retina, that is particle nature. Remember this. You may get 1 mark question. Absorption of light by retina. Write down this. Absorption of light by retina. Retina. Present in the, it is like a screen. You have an eye, right? Here you have a lens and you have a retina where the image formation occurs. Image formation occurs in the eye. It's a screen of the retina. Screen of the eye. So what happened in 1924, de Broglie was a scientist who put a hypothesis. What did he say? What did he say? 1924, there's a person called de Broglie. He put a hypothesis. He said The nature is symmetrical. Symmetrical. Why symmetrical? You see, you have a tree. What is symmetry? If I put a mirror, then both this side and that side is one of the image mirror image of each other. Similarly, let us you have a human. Yes, if I put a mirror or if I cut the human in two halves, this part will be exactly equal of this part. So nature is symmetrical. Okay. Second, if radiations can behave as particle, okay, radiation can behave as particle and also wave. Radiations behave as particle and also like wave. Third, he says particles, radiations can also behave like particle and also can waves. And what he said, he got a Nobel Prize for proving that every moving object has or behave like a wave, or every moving object or a particle has a wave associated with it. And this for this he got a Nobel Prize. D. Broglie got a Nobel Prize. We'll study about this. We'll study about what it, and these waves are called matter waves because these waves are associated with the matter. Object is a matter, particle is a matter. Anything and everything in this, anything and everything which has some space, which has some weight, occupies some space is called matter. Since these waves are associated with the matter, these waves are called matter waves. Any doubts till now? Any doubts?
No, sir.
Okay. So now the sorry, have you written down? Shall I rub it? Shall I rub it?
Sir, 2 minutes, sir.
Okay. Okay. So now we will see the wave. What is the wavelength of those? Every wave has a wavelength, has a frequency, has a time period, everything. So what is this wavelength of these waves? So that wavelength of these waves is given by h by p. And what is this h? You know what is this h? Planck's constant. Yes. And what is this p? Momentum of the particle. Similar as photon. That means any object, let's say you have an object m, which has a mass m, and is moving with a speed velocity v. So what is the momentum? The momentum will be p equal to mv. Yes or no? So you know the momentum. Yes. So every object, you know the mass, you know the velocity, you will be able to find. So that means you have a football, okay, which is maybe 300 grams, and you have a ball, cricket ball, which is 120 grams. This is moving at a speed of 100, 300, 100 kilometer per, no, that not that much, maybe 60 kilometer per hour. And this is moving at 150 kilometer per hour. So what will be the momentum? The momentum will be 60 into 300. You have to convert it into kilos, 300 by 1000. And this will be 120 by 1000 into 180 kilometer per hour. So you got the momentum. You got the momentum and you know the h. Since both the momentums are different, so the lambda will be more or high? Tell me, which will be more? Which lambda will be more? This lambda will be more or this lambda will be more? Which one?
The second one.
Are you sure? 15 into 12. 30. 15, 30, 15. So 180, right? 180, 1800. No, 18,000. This is also 18,000. Same, no? Same, no?
Yes.
So
Same.
the lambda for both will be same. Okay. The lambda for both will be same because this also 18,000, 18,000 by 1000. Okay. Here also same. So the lambda will, so you can find out the lambda. Clear? Advait, clear? How to find lambda?
Yes, sir.
Advait? Hello. Advait, can you hear me?
Yes, sir.
तो बताओ बात करो पूछ रहा हूं मैं तुमको कुछ
No, sir. What?
so this lambda so this formula can also be written as lambda equal to h by mv. Write down this formula, very very important. So what we infer that if there are two objects, one is a bigger object, one is a smaller object, obviously this mass and this mass, your m is greater than m, okay, both are moving in the same velocity. So lambda is small for mass greater. That means the lambda here and the lambda here, lambda 1 will be smaller than lambda 2. So lambda 2 will be greater than lambda 1. And this mass, small mass. That means lambda and the mass are what? Inversely? Inversely
Inversely proportional.
perfect. Clear? So if you have a larger mass, you cannot observe. It is difficult to observe. It is difficult to observe waves for a bigger or greater mass. Why? Because lambda is very, very small. Maybe your lambda will be something like this small. This small. It cannot be. You need to have, generally I can measure a wave. One wavelength is one wave, this one is one wave. Okay. Again, this is one wave. Here you can see very feeble, very small, very small. So for bigger objects, it is difficult to observe lambda because lambda is very, very small. Clear? Yes? Yes or no? But for lighter particles, it is easy. Why? So lighter particle has a bigger lambda. So it is very easy to observe. Write down. Clear?
Yes,
So
sir.
for electron, proton are very very easy. You can watch. You can see this. So lighter the particle, larger the wavelength. Heavier the object, smaller the wavelength, and difficult to observe. So do a problem. A mass 100 kg. There is an object of mass 100 kg. Okay, moving at a speed at 10 meter per second. What is the lambda? Find out the lambda. H is equal to 6.626 into 10 to the power minus 34 joule second. Find out what is the lambda. Faster.
Sir, it will be 6.626 into 10 raised to minus 30.
Why?
Sir.
Why?
Sir, sorry, it will be 38 minus 38.
What? No, no, wrong. 6.6 into 10 to the power minus 38. No, it will be
Yes.
6.6 minus 37. So lambda equal to h by p. So 6.626 into 734. And down you have 100 into 100
10.
into 10. Huh? Correct. So down top it will go 10 to the power minus 3. That's all. How much?
Yes. 37.
How much?
Yes.
31 watt. What it is?
Thir-
Meter. Meter. So if it is kilometer per hour, convert it to meter per second. Okay. If this is meter per hour, kilometer per hour, convert it to meter per second. Okay. Okay. Do you know the conversion? 10 meter per second. If you
yes.
want to convert into a kilometer per hour, divide 5 by 18. Yes or no? Do you know?
Yes, sir.
Are you sure? This or 18 by 5? I forgot. 18 by 5, 36. 36 kilometer per hour. 36,000 divided by 1000. Sorry, 60. No, I think it's ulta. 5 by 18, I think. Yeah, correct. So if you want to convert meter per second to kilometer per hour, divide by 18 by 5. Okay. 10 meter per second into 18 by 5. So this will be 2. So you'll get 36 kilometer per hour. If you want to convert to kilometer per hour, then what? Multiply 5 by 18. Clear? Clear? Advait?
Yes.
Meter per second to kilometer per hour. Multiply 18 by 5. Kilometer per hour to meter per second. Multiply. Fine. Fine, Advait?
Yes, sir.
Okay. So now, let us, for example, we'll consider a electron. We want to find out the de Broglie waves, matter waves for electron. So let's, you know, the mass of the electron is 9.1 into 10 to the power minus 31 kg. It is moving at a speed of 10 to the power 6 meter per second. Then what is the wave? Lambda will be 6 h by mv. What is h? 6.626 into 10 to the power minus 34 joules second divided by mass is 9.1, 10 to the power minus 31 kg into 10 to the power 6. Correct? So 31, 34. So remaining is minus 3. This goes. So it will go, this will go up, so it will become minus 9. So 6.626, sorry, divided by 9.1 into 10 to the power 9. That's all. So how much it comes to? If you want to take this will become 0.73 into 10 to the power 9 meter. So if you want to write it, it will be 7.3 into 10 to the power 10 meter. So that means 10 means how much? Angstrom. So we can write as 7.3. Clear? Okay. Both of you?
Yes, sir.
See, always it is 0.733 into minus 9. Try to take this side so it will increase. So we are written You know 10 to the power minus 10. 1 angstrom is how much? 10 to the power minus 10 meter. So we got 7.3. It's very, very small. Clear?
Yes, sir.
Yes, sir.
So what we found, we saw that de Broglie waves or de Broglie hypothesis is not for daily objects. Is not for daily objects like car, bus, because they're very big. It is basically for what objects? Quantum objects like electron, proton, neutron, quarks, photons, only those objects. Okay? If somebody asks you why we are not able to see de Broglie waves, because these objects are very big. Very, very, very big. Okay? You see, for electron only we got how much? 7.3 angstrom. For electron. Being this small we got. So you think if you have a ball, how much it will be? It will be how much? Maybe 0.000000000000000. Keep on going. That much small. Maybe 10 to the power 100 or something. That much small. You cannot even see that. Clear? Clear or not?
Yes, yes, sir.
So it is only for quantum objects like electron, proton, neutron, quarks, photons, such type of objects. Not for bigger objects. Okay? So now we will study the kinetic energy of a particle. Kinetic energy of a particle. Kinetic energy of a particle is equal to how much? Formula is half mv square. Yes? Yes or no? So you know P is equal to mv. Yes? Then can I write this as half into mv into v? Yes? Yes?
Yes, sir.
Yes, sir.
Then I can write this as v by 2 into p. This is p. Yes?
Yes,
Yes,
sir.
sir.
Then what I'll do, I will multiply again a p, and I will divide by 2m. No. I will divide by m. So see what it becomes. It becomes mv into v divided by 2m. So this goes, okay. Somewhere I made a mistake. P square by 2m is how much? Okay. Yeah. So see, I had this v into p. Now I multiplied, I divided by m and multiplied m. Can I do that? Can you do that?
Yes,
The value is unchanged. So this mv becomes what? This mv into p becomes what? P into p and divided by 2m. So can I write this as p square by 2m? So kinetic energy half mv square. Another formula is p square by 2m. Clear? Yes?
Yes, sir.
So
yes,
now,
sir.
so I can write, my formula was lambda equal to h by p. Okay. Now, p square by 2m is equal to kinetic energy. So can I write p square as 2mk? Possible? Can I write? This will get multiplied, no? Cross multiply. Then p will be
Yes, sir.
2mk root over. Can I write?
Yes,
Yes,
sir.
So then here, can I substitute instead of p 2mk? This is a new formula. This is a new formula for lambda. If you have kinetic energy given and the mass given, you can find out lambda. Okay. Okay,
Yes, sir.
Yes,
Yes, sir.
sir.
great. Write down, note down. So the first case was lambda in terms of kinetic energy of a particle. Okay, lambda in terms of kinetic. Now second case, this is the first case. Second case will go is lambda in terms of accelerating potential. What happened? I applied a potential, okay, and here I have a charge. This charge will go towards the positive because this is an electron. So this charge will go towards the positive electron. No, electron will go to the positive potential. So then, what is the work done? The work done will be Q of delta V, the change in potential. The change in potential will be 0. If you have electron, it will be minus E into V. Okay. Yes or no? Or I can write it as minus QV. So the work done in accelerating potential is minus QV. Okay.
Yes, sir.
And what is this work done? This work done, the work done is or is work done, work is done on the expense of the kinetic energy. So this kinetic energy is same as the work done, which is equal to QV, which is same as the QV. Now we already got the formula for lambda was h by root of 2mk, correct? So can I substitute instead of k 2m qv? Yes or no? Yes.
Yes,
Yes,
sir.
sir.
So there is another formula. If you have a voltage given, okay, you can still find out the lambda. And this formula will further for electron, the formula simplifies equal to lambda equal to root 150 divided by V. That's all. It's only for this for any charge. Huh? This is for any particle. If you have proton, then you have to substitute the value of the proton, the charge of the proton voltage. This is only for what? Electron. Only for electron.
Electron.
What else? Clear?
Yes, sir.
Yes, sir.
Or you want to further simplify? You can write lambda E, or you can write lambda E is equal to 12.27 divided by root of V. Same formula. Root of 150 is nothing but 12.27. Root of 150 is equal to 12.27 approximately. Whichever you want to use, whichever you feel comfortable, you can use. Only for electron, again and again I'm saying, this is for only for lambda E. If you have proton, then you have to substitute the value of the proton, neutron. This only, normally your question will come only for electron. You are targeting the boards only. For other people who are targeting other, then you have to consider. Only boards, it's only for your question come electron. If at all the meeting goes off, please rejoin. Okay, rejoin instantly.
Sir,
Yeah,
sir, can you give the value of lambda for neutron and proton also? Like,
we have to. I have to give you. I have to do and give you them. I will
Okay.
do it. I will do it later and give you. See, proton, proton will be different. Proton and neutron will be same, almost same.
Yes.
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 So I will give you that. Okay. I will send you in the
Yes,
next.
sir.
I maybe I'll WhatsApp you, or I will tell in the next class, Wednesday class.
Yes, sir.
This is simpler formula, no?
Yes.
So we'll do a problem. Find the de Broglie wavelength of an electron associated with it, accelerated through a potential V is equal to 100 volts. Find the lambda. Use the formula. Lambda equal to 12.27 divided by V or 150 by V. Anything. Tell me the answer quickly. And always the answer you get this formula, no, is in angstrom, by the way. Angstrom. Don't write in anything
Okay.
else. Don't write meter, picometer, heptometer. Only in angstrom. The value will be into 10 to the power minus 10 meter.
Sir, it will be 1.227.
Yeah, very good. अद्वैत तेरे को आया? अद्वैत? What is this, अद्वैत? ये ऐसा क्यों लिखा जाता है? क्यों है ये? क्यों है? इसको बोलते हैं अप्रोक्सीमेशन. समझा? अप्रोक्सीमेशन. इक्वल नहीं है, लेकिन थोड़ा ऑलमोस्ट इक्वल. Clear? An electron, an alpha particle and a proton, और एक क्वेश्चन है. An electron, a alpha particle मतलब क्या है? Helium 2 plus and a proton have same kinetic energy. उसका kinetic energy same है. Which of the particles has shortest de Broglie wavelength? Which particle has lambda shortest? Lambda किसका small है? किसका small है? तो मुझे बताओ, लैम्डा किसके ऊपर डिपेंड करता है? लैम्डा किसके ऊपर डिपेंड करता है? मास के ऊपर डिपेंड करता है कि नहीं? मैंने बोला था.
हाँ.
तो लैम्डा इज इनवर्सली प्रोपोर्शनल टू द मास.
Mass.
लेकिन जब फॉर्मूला रहता है एच बाई पी, जब काइनेटिक एनर्जी रहेगा तो मास के किसके ऊपर डिपेंड करेगा? रूट टाइम के ऊपर डिपेंड करेगा. क्यों? क्योंकि तुम्हारा जो फॉर्मूला है एच इक्वल टू लैम्डा इक्वल टू एच बाई 2m के रूट ओवर है ना. तो ये किसके ऊपर डिपेंड करता है? इनवर्सली प्रोपोर्शनल टू रूट ऑफ m,
Root M.
है ना. तो जिसका ज्यादा बड़ा लैम्डा,
Yeah.
सबसे बड़ा लैम्डा किसका है? मास किसका है? हीलियम न्यूक्लियाई का. तो अल्फा का जो मास है, मास फॉर अल्फा इज ग्रेटर देन मास ऑफ प्रोटॉन विच इज ग्रेटर देन मास ऑफ इलेक्ट्रॉन. तो आपका लैम्डा ऑफ अल्फा इज स्मॉलर, फिर लैम्डा ऑफ प्रोटॉन, फिर उसके ऊपर लैम्डा ऑफ इलेक्ट्रॉन. मतलब जिसका छोटा मास उसका ज्यादा बड़ा क्या? वेवलेंथ. जिसका बड़ा मास उसका छोटा वेवलेंथ. आया समझ में? अद्वैत आया
हाँ
समझ
सर.
में? काइनेटिक एनर्जी सबका सेम है, लेकिन मास अलग है. न्यूक्लियाई जब आएंगे ना तो पढ़ेंगे. हीलियम न्यूक्लियाई बड़ा है. एक हीलियम न्यूक्लियाई बहुत बड़ा रहता है. हीलियम न्यूक्लियाई एक कितना रहता है? हीलियम में क्या रहता है सिद्धि? हीलियम में कितने इलेक्ट्रॉन कितने प्रोटॉन रहते हैं? 2 इलेक्ट्रॉन, 2
Two.
प्रोटॉन, 2
Two
न्यूट्रॉन.
proton, two neutron.
हम बात करें एक इलेक्ट्रॉन एक प्रोटॉन, ऑब्वियसली ये बड़ा है ना.
हाँ.
ये सबसे बड़ा है. तुमको पता है प्रोटॉन इज 1000 टाइम्स हेवियर देन इलेक्ट्रॉन.
Yes.
ये है 9.1 इंटू 10 टू द पावर माइनस 31. ये है 9.1 इंटू 10 टू द पावर माइनस 27,
27.
है ना. तो ये 1000
हाँ.
टाइम्स ऑलमोस्ट बड़ा है. आई थिंक 9 पॉइंट नहीं कुछ रहेगा, मेरे को याद नहीं आ रहा है. 1000 टाइम्स हेवियर. ये n हुआ तो ये 100 n हुआ. समझा?
Yes, sir.
नोट किया अद्वैत?
हाँ सर, किया नोट सर।
फटाफट ज्वाइन करो, मैं मीटिंग स्टॉप कर रहा हूँ, फटाफट ज्वाइन करो।
हाँ सर।